So welcome back. In our previous video we stopped at where we were explaining bounded functions, like functions that are bounding, and we're able to get our limit of epsilon of x when x tends to 0 to be equal to 0. So that means for when n is equal to 3, the function admit bien and dl. So we'll write finally what our answer would be. So we have, in this case, f of x will be equal to 1 plus x plus 2x squared plus x raised to the power of 3 plus x raised to the power of 3 x squared sinus 1 over x, where this is our epsilon of x. And epsilon of x, it tends vers 0 when x tends vers 0. So now we'll go for when x is equal to 4. The same principle. In our last video, I explained to us that if we're asked to go to maybe the order of 4, but we don't have, in this case again we are stopping at 3, there is no plus something x raised to the power of 4. We create that, we assume it's 0 x raised to the power of 4. That's why the x raised to the power of 4 is not written here. So if we are going to the order of 4, so we'll change this to n equal to 4. If we are going to the order of 4, it means an x raised to the power of n. So a4 x raised to the power of 4. And x raised to the power of 4, it means here we have a 0 x raised to the power of 4, like I said. So that means our a4 is 0. And because that's 0 multiplied by x raised to the power of 4, we have 0. So that's why probably it's not included here. So that means here on our own, we are going to, at the order of 4, we are going to include that it is 0 x raised to the power of 4. So I'll clean this so we'll have better view. So we'll have here f of x is equal to 1 plus x plus 2x squared plus x squared, x cubed plus 0x4 plus x raised to the power of 4. If we factor out x raised to the power of 4 here, we'll be left with x. So we have x sinus 1 over x. So this would be our epsilon of x. The same thing applies, like the limit of x sinus 1 over x. Sinus 1 over x is bounding. We multiply it by a function that tends vers 0 when x tends vers 0. So the limit will be 0. And so therefore epsilon of x tends vers 0 when x tends vers 0. So it is also bien défini. So at n equal to 3 and n equal to 4, the function admit bien and dl. So finally for n equal to 5, maybe you can also try for n equal to 5. So you can pause this video and try out n equal to 5. So for n equal to 5, it means we have an x raised to the power of n. That's a5 x raised to the power of 5. The same thing here. We don't have it here, but we can create it. I don't know if you can see that right there. But we can create 0 x raised to the power of 5. So that means we'll be having f of x is equal to 1 plus x plus 2x squared plus x cubed plus 0 x raised to the power of 4 plus 0 x raised to the power of 5 plus x raised to the power of 5 sinus 1 over x. Here we don't have to factor out anything because our order stops at 5. So that means this is our epsilon of x, because we know it has to be x raised to the power of n epsilon of x. So here we have x raised to the power of 5, and so epsilon of x is this. In this case, does the limit when x tends vers 0 of sinus 1 over x, what is the limit? Will it give us 0? So I'll do it right here quickly. So the limit, wow, See this? It's a lot of ink. So limit of x when x turned by 0 of sinus 1 over x, it doesn't exist. I'll tell us why. Because if x turned by 0, it means we are going to make this to be 0, sinus 1 over 0. And 1 over 0, it's infinity. So sinus infinity of exists upper. So generally, the limit of 1 over sinus, the limit of sinus 1 over x when x turned by 0 doesn't exist. So it means our limit of exponential x of epsilon of x as well doesn't exist, because this is epsilon of x, and so the limit doesn't exist. And so that means when n is equal to 5, f of x doesn't have a dl because it doesn't verify the last part of the rest. So in general, for n equal to 3, n equal to 4, the limit exists, the dl exists. But for when n is equal to 5, because of this condition, the dl doesn't exist. So thank you for watching. In our next video, we'll be doing more exercises. And again, if you haven't subscribed, you can click on the subscribe button below. If this video has helped you, you can click on the like button. And see you in the next video.